Happy Friday, everyone. I don't want you to fall behind the other classes, so I'm giving you a video on Unit 2, Lesson 13. We have a unit test coming up next week, so I thought this wouldn't be a bad idea to go through this. It shouldn't take very long. All right, so it would be a good idea if you have this worksheet, so you can use that as a reference, okay? This is Unit 2, Lesson 13, Proofs of Quadrilaterals. And the first thing, if you want to grab a ruler, you know where they are over in the toolbox. Actually, you can just use the protractor because it has the ruler on it. You're going to need the protractor for measuring some angles. And this is optional, but it might help you understand better if you actually do the activity. You can always pause the video. Okay, so we are going to fill in this chart by answering these questions. The diagonals bisect each other, okay? And we have to check to see if they bisect each other in the parallelogram, the rectangle, the rhombus, the square, and the kite, and all of these pictures are here. All right, so when we think of the word bisect, it's cutting it in half. So if we look at these diagonals, are the diagonals bisecting each other? So is it cutting them into two congruent parts? Here and here. Well, if you want to pause the video and actually go ahead and measure these to see if they are equal on each side there, go ahead and do so. And then come back. Okay, so it turns out they do. And you can see it here, but it's a good idea to, verify it by measuring. It also helps you learn it better. All right, with the rectangle, same thing. If you want to pause the video, you want to see if they are congruent and these are congruent. Go ahead and pause the video if you want to go ahead and measure. Okay, so it turns out not only does it bisect, but we're going to see this later, these are congruent. So they are all the same length from here to here, where they weren't with the parallelogram. You can see that this is longer, okay? And we'll be measuring that later too. All right, so with the rectangle, they do bisect each other. With the rhombus, okay, so this is a rhombus square. If we look at an actual rhombus, all right, and look at the diagonals of that, well, it's written right on here. Diagonals bisect the angles. Oh, no, not that. I don't want that one. Where is it? Oh, diagonals are the perpendicular bisector of each other. So they do bisect, okay? And that statement is saying it. But if you want to go ahead and on this sheet, measure those diagonals, okay? And then see if where they cross, if it's the same distance from here as it is to here, right? I had one where it was written on there, but I don't want to mess this one. I guess it doesn't really matter. Let me just do this. So if I draw it in there. So you want to see if these are congruent and these are congruent. Okay? So go ahead and pause the video if you want to. All right, so are the diagonals bisecting in the rhombus? They are. So let's go ahead and check that off. And also with the square. All right, and you can actually see that here because this is a square. So I'm going to just go ahead and mark these, and they're all the same length. What I want to add about squares is squares are at the very bottom here of this whole quadrilateral chain. So at the top, these properties are the same for all of these, right? This is 4 sides, and the interior angles add up to 360. So that's the same for a parallelogram, rectangle, rhombus, and square. All of these characteristics or properties of the parallelogram are the same for the rectangle, rhombus, and square. And then these two are on the same level, but they don't have the same properties. However, both of those, all of these properties and all of these properties are properties of a square. So the square gets everything. So everything above the square, the square has all of those properties. So we can say a square is a rhombus, but you can't say a rhombus is a square. You can say a square is a rectangle, but you can't say a rectangle is a square. All right, so that's how it works. And then you have kite over here with its own properties, but with the first two here, the quadrilateral, those two properties are also the properties of a kite. And then those are the kite's properties. So you can always refer to those while we're doing this as well. So yeah, we can check off square. And then in the kite, the only diagonal that gets bisected is this, because if you look at your sheet, notice what it says right here. One diagonal is the perpendicular bisector of the other. All right, so going back to the picture, this is the perpendicular, perpendicular bisector, this diagonal right here, of the other. So we can put a right angle in there. So that means that we have two, these two are congruent. This diagonal gets cut into two congruent pieces. Okay, so on this we have to just put only one diagonal. Okay, so now we want to know, are the diagonals congruent in a parallelogram, rectangle, rhombus, square, and kite? So looking at the pictures, if you measure this, you're going to see that this is longer. It has this elongated shape, right, on each side. So that diagonal is always going to be longer, which is also the same for a rhombus, right? This one's a little bit longer, and you can measure that if you want to. Again, it solidifies it if you actually go through the motions. So if you want to measure, go ahead and stop and then come back. All right, so in a parallelogram, are the diagonals congruent? No. In a rectangle, yes. If you measure those, you can see that they are the same. And I know they are because these are all congruent, right? So they have to be the same length. So we can check off rectangle, they're congruent. Rhombus is like a parallelogram. It's got that elongated shape, right? Just a little bit. But, so those diagonals are not congruent. And then in the square, yes. And then obviously in the kite, it's not. It's longer this way than it is this way. Moving on to bisect opposite angles. So, oh, it is. I was thinking I didn't think the video was running. I just saw the time. Yes, we're good. So do the diagonals bisect the opposite angles? So that means, let's go over to the parallelogram. So we're talking about this right here. Does it bisect these? Meaning, are these congruent? If you measure these with your protractor, you set your protractor right on here. This is your vertex, so that's where the whole of the protractor would go. And you're going to see, when you measure these two angles, that this one is bigger. Okay? What we do have, because the opposite sides are parallel, we know that this angle will be the same as this angle, and this angle will be the same as that angle. All right, so that's one thing we do know. All right, so in a parallelogram, the opposite angles do not get bisected, so we'll skip that. In a rectangle, it's the same thing. Okay, so these right here and these here. All right, so the opposite angles of a rectangle do not get bisected. Okay, someone's knocking at my door. Hold on, please.